Okay, in this presentation we're going to look at continuous joint probability distributions. So this relates to probability distributions where we're looking at the integrals to calculate the marginal probabilities, the expectations, etc., etc. So in this example, we have a certain farm produces two kinds of eggs that on any given day, organic and non-organic. Let these two kinds of eggs be represented by the random variables x and y. Given that the joint probability density function of these variables is given as follows. F of xy equals 2 over 3 times x plus 2y, where x is some value between 0 and 1 and y is some value between 0 and 1. Pay attention to those because those give us the integrals for integration later on, or those are indicative of where we should be going to look. Okay, and 0 otherwise. Okay, so really x and y is essentially what we're asked to do is find the marginal probability distribution functions of x and y and calculate the probability of x being less than a half and y being less than a half. Okay, the joint probability there. Really this question doesn't really tell us much about how these relate to eggs, to be honest with you, but we'll just keep going anyway. So, first off, exercise A, let's calculate the marginal probability density function of x, and this is calculated by integrating the joint probability density function there, f of xy, x and y, over all of the possible values of y. And remember, I said that all of the possible values of y, they are between 0 and 1. So essentially what we're doing there is f of x equals the integral of the joint distribution function f of xy with respect to dy, okay? So that is, and we recall our joint distribution function, it is 2 over 3 times x plus 2y. Okay, so essentially what we're going to do is integrate that with respect to y from 0 to 1. So our limits of integration are 0 and 1. So let's get into it there. So the top line there is f of x equals integral from 0 to 1 of 2/3 times x plus 2y dy. So far, so good. What we can do there is take out the 2/3. Okay, it's just a constant, so we just move it out in front of the move it out to the left of the expression. Okay, so we can break up our x plus 2y into two distinct integrals. Okay, and so we have the integral of x and the integral of 2y dy. Okay, now x is a constant in terms of y, so we can actually split that out in front of the integral as well. So essentially we have 2/3 times x times the integral from 0 to 1 dy, okay, and that's just going to end up as y, okay, plus 2/3 the integral from 0 to 1 of y dy, okay. So that will end up as y squared over 2. And remember, we're taking the 2 out of that integral as well. So just tidying things up and evaluating them. So you have 2/3 times x, y evaluated from 0 to 1, okay, which is 1 minus 0, which is 1, okay, plus 2 times y squared divided by 2 evaluated from 0 to 1. So y squared when it's equal to 1 is just 1 squared 1 divided by 2, and 0 squared divided by 2 is just 0. Okay, so that actually works out to be 1 over 2 times 2, okay, which is 1. So tidying it all up, our joint distribution, our marginal probability density function for x is 2/3 times x plus 1. Okay, so really this is a straightforward integration and you should be able to cope with that. It's just an application of the standard integration rules that you would have learned in previously. Okay, then that's just the full statement there. It's always helpful to put in that little statement there, the support 0 is less than or equal to x, less than or equal to 1. Okay, it's just the A1 answer. Okay. We're going to do something similar here for the marginal PDF of y, the marginal probability density function of y, and that is same sort of a calculation, integrating the joint probability density function f of xy over all the possible values of x. So just the same thing really, but just with respect to x rather than y. So f of y equals the integral from 0 to 1 of the joint PDF, the joint probability density function, dx, okay? And recalling that the joint density function again is 2 over 3 times x plus 2y, okay? So what we're going to do again is split it up into two parts. We're going to take out the 2/3 out of the integral altogether and put it on the right and the left hand side of the expression. And we have the integral of from 0 to 1 of x dx, okay, that's going to be x squared over 2, plus 2y dx, okay. Now 2y is a constant as far as x is concerned. It's a constant as, in terms of x, so we take the 2y out of the integral there as well. So we have an integral from 0 to 1 of dx, or 1 times dx essentially. So, evaluating the definite integral of x squared divided by 2 gives us 1 squared minus 2 minus 0 squared minus 2, which is going to end up as 1/2. Evaluating the definite integral of x from 0 to 1 is 1 minus 0, so we end up with 1. And recall, we have the 2y there as well, which was a constant for this integral, okay? So we have essentially 2y times 1, 2y. So the joint probability density, the marginal density function for y, f of y, equals 2/3 times 1/2 plus 2y. You can tidy that up a little bit more and express it as 1/3 plus 4 over 3y. Okay, I had to pause the video there for a second because my assistants, my canine assistants, were beckoned to do jobs in the backyard. So anyway, we'll move on. I'm not going to stop things just for that. Okay, we'll move on to the last question. So, and this is exercise C. Find the joint probability of x being less than or equal to 1/2 and y being less than or equal to 1/2. So the joint probability again is 2 over 3 times x plus 2y. Now this is the important bit here because this gives us a lot of information that we will need, particularly when we need to determine limits of integration in various calculations. Particularly in this case, the lower bound of a limit of integration. So here the limits of integration are derived in this. This is the support of the function 0 less than or equal to x less than or equal to 1, and 0 less than or equal to y less than or equal to 1. Okay. Now those are going to, the zeros there are going to be the lower bounds of the limit of integration, the lower limits of integration in the calculation that we're about to see. The probability of x less than or equal to 1/2, y less than or equal to 1/2, those are going to be the upper bounds. Okay, so we have a double integral there. In both cases, the internal integral and the external integral are integrals from 0 to 1/2. The joint probability density function is in there, 2 over 3 times x plus 2y. And we are going to integrate it with respect to x first, and then with respect to y. Okay, so essentially we have the internal integral, which essentially we're going to integrate with respect to x, and then that one, the result of that, we'll integrate with respect to y. Okay, and use those limits of integration. So let's perform it step by step. So essentially what we're going to do here is just pick out the internal integral. Okay, so we have the integral of 2/3 times x plus 2y dx. Okay, so essentially we're going to move that 2/3 out to the left hand side of the interior integral. Okay, so essentially what we're doing there is integrating x plus 2y dx. Okay, so that is x squared plus 2yx. So our limits of integration for the definite integral are 0 to 1/2. Okay, so in both cases that will work out to 0 for the lower bound. Okay, so essentially what we have to do there really is just evaluate it at the upper bound, which is 1/2. So we have x squared, which is 1/2 squared, which is a quarter, and we're going to divide that by 2. So we have 1/8. Okay, and we have 2y squared. 2yx. Well, if x is a half, the 2 and the half cancel out, so we just have y. So we end up with an integral from 0 to 1/2 of 2/3 times 1/8 plus y dy. Okay, so the second part, the external integral, for want of a better word, just to sort of differentiate it from the internal integral. Okay, so this will complete the job we have to do. So again, we're going to take out the 2/3 and move it to the left-hand side of the integral. And it's going to stay out there right to the very end now. Okay. An integral from 0 to 1/2 of 1/8 plus y dy. Okay. Well, the integral of 1/8 with respect to y is 1/8y. The integral of y is y squared over 2. Okay. So evaluating the upper and lower bounds of the definite integral, and again we can sort of disregard 0 here. It's worth paying attention to, but the fact that it's 0 is really helpful, and we don't have to do much with it. Really, we just have to integrate or evaluate it at the upper bound, which is 1/2, and we can disregard the lower bound because it's 0, and it all cancels out, and everything is an expression in y, so it's all gone anyway. There's no constants left, so we're good. Anyway, y equals 1/2, so 1/8 times 1/2 is 1/16. Y squared over 2 is again 1/8, so we have 1/16 plus 1/8, okay, which is 2/16. So we end up with 2/3 times 1/16 plus 2/16, which is 3/16. So 2/3 times 3/16 essentially works out to be 2/16, which is 1/8. So that is the probability that we are required to calculate. The joint probability of x being less than 1/2 and y being less than or equal to 1/2. It is 1/8 or 0.125.